Okay, in this video we're going to go over the notes for circumference and arc length. Circumference is the distance around a circle. I can call the circle O. Diameter is a segment with endpoints on the circle, and the midpoint is at the center of the circle. So here's the diameter D. Radius is a segment with one endpoint at the center of the circle and the other endpoint on the circle, and it's half of the diameter. So there's the radius R. The circumference formula is C equals pi d, or C equals 2 pi r. Okay, example number 1. Find the circumference of a circle with a radius of 7 centimeters. Okay, so we're looking for circumference and we're given radius. So I can use C equals 2 pi r, substitute 7 for r, and I get 14 pi centimeters, or roughly 44 centimeters. Example 2, I know the circumference and I'm looking for the diameter. So I'll use C equals pi d, substitute 64 pi, and solve for d, and I get 64. Example 3, I have a circle inscribed in a square with 10 inches. So that means the diameter must also be 10 inches. I can use the C equals pi d, and I want it in terms of pi. So when I get my final answer, I get 10 pi inches. Example 4, I'm given the circumference, 32 pi centimeters, and I'm looking for the radius. So I can use C equals 2 pi r, make my substitutions, solve for r, and I get r equals 16 centimeters. Find the terms below and show in a sketch. So arc length is the distance of a portion of a circle. It's a fraction of the circle's circumference. So I'm going to make a little sketch here to use for all of these terms. So an example of an arc length would be arc MN or arc PQN. Central angle is an angle with a vertex at the center of a circle, like angle MON or angle POQ. A semicircle is an arc that is half of a circle, like arc PMN and PQN. A minor arc is an arc with a central angle less than 180 degrees, like arc PQ or arc PM or arc NQ. A major arc is an arc with a central angle greater than 180 degrees, like arc MNQ. Adjacent arcs are arcs on the same circle that share exactly one point, like arc PQ and arc QN, or arc PM and arc MN. They share the same point on that circle. Okay, an acute central angle is a central angle less than 90 degrees, like angle POQ. An obtuse central angle is a central angle between 90 and 180 degrees, like angle QON. Okay, example 5, we're going to identify the following types of arcs. 2 semicircle arcs. This would have a central angle of 180. Major arcs have to be greater than 180 degrees for the central angle. Minor arcs would be less than 180 or less than a semicircle. Adjacent arcs on the same circle, but they share a common point, only one point. Obtuse central angles got to be greater than 90 but less than 180, and an acute central angle's got to be less than 90. So in example 6, we're actually going to find the measure of these angles, and we're given one right angle in the figure, and from that we can deduce all of the other angles. We also know that the segments AB and ED are diameters, so effectively they're cutting the circle in half, or semicircles, and we get all our answers. And I encourage you to write the angle measures on the drawing as you find them. Arc length formula. Arc length equals the central angle divided by 360 times 2 pi r. Well, this is just taking the fraction of the circumference, which is 2 pi r. So in example 7, we're looking for arc PQ, and we're given the central angle is 60 and the radius of 9. So I make my substitutions. I can do a lot of simplifying here of the fractions, and I get 3 pi, or approximately 9.4. In example 8, we're looking for the radius if we're given the arc length and the central angle of 90 degrees. So I use the same formula, and this time I'm solving for r, so when I divide pi to both sides, pi's cancel, and I end up getting 12 for my radius. And that's it. So I hope these video notes were useful to you. I'll see you next time.